This is a demo of a simple thread and a simple runnable object so that you can see how to make threads go in Java. If you are following along with the source code, it's in the simple thread folder and the simple runnable folder are the things that we're going to be looking at for this particular demo. So a simple thread can be made by just extending the thread class that gives you all of the different methods that the thread has, and thread has a string you can call the superstring method, and it will call the super constructor. The most important thing, of course, is the run method, and in this little simple example, my thread has a run that just loops 10 times, and it prints out what iteration of the loop it's on plus the name of the thread, and the name of the thread is this string that goes in. So that's what that get name call, that's a superclass method, and we call it, and it gives the thread's name back. And then the thread's going to sleep for a random number of seconds, and then it's going to wake up and it's going to do it again until it gets to 10. And then it will print done when it reaches the end, and that's the end of the thread. And so I can test this by just running it and make a new simple thread with Guelph and a new simple thread with Waterloo. When you're starting a thread, you have to call their start method. So I can call start, that automatically calls the run method. A little confusing, but that's how it's done. And if I run this, it'll come out and it'll print Guelph, Waterloo, Guelph, Waterloo. And you'll notice that we've got a Guelph, 2 Waterloos, 3 Guelphs, a Waterloo, a Guelph, 2 Waterloos. And this is the time slicing that I was talking about in the earlier slide deck. It isn't going to be the same every time we run it. So if I run it again, I'm not going to necessarily get the same slicing. So here it goes Guelph, Waterloo, Guelph, Waterloo, Guelph, Waterloo, and then another Waterloo, and then it just does it differently. And this time Guelph got done first, and Waterloo got done second. The first time I ran it, it happened the same way. Guelph got done first, and Waterloo got done second. But even that's not guaranteed. So those threads are just sliced by the scheduler, or the time is sliced, and the threads are allocated resources. So that's a very, very simple thread application. There's a thread class, we run it, and things happen. Okay, so that's the basics of thread extension. The other one I want to show you is just using the runnable class. So if you already have a class that is extending something else and you can't extend thread, you can just implement runnable. If you remember, in Java, you can implement as many interfaces as you need to, so you can always implement runnable. Runnable is a functional interface, so it only has this one required method that is run. There's nothing else. This means that you can do it with lambdas if you want to. I'm not going to demonstrate that here today. This runnable task does nothing except get the name of the current thread and then prints out hello and the thread name. So the runnable test for this one, there's a runnable task. We make a new runnable task. I'm going to run the task in the current thread, and then I'm going to make a new thread and send it the task. Okay, so I'm running that task twice in this example. So if I run that, and it'll print out hello main because that's the name of the main thread, and then hello thread 0 because that's this first thread that I'm in. If I comment out this and give us a new thread T2 equals new thread and hand it the task, now that task will run in two subthreads and not at all in the other thread, in the main thread. And it doesn't like me. Why don't you like me? Oh, I didn't start T2. That's always useful. Yeah, thread won't execute unless you start it. Let's try that again. And then we get hello thread 0 and hello thread 1. And so there's the very quick example of how to make something runnable.